Welcome, everyone. Let's jump right in. I am absolutely thrilled to have you here for today's explainer, which we've structured as a step-by-step classroom lecture. We're going on a totally fascinating journey into something that literally powers almost every single aspect of our modern world. And yet, honestly, most of us rarely stop to think about how it actually gets made. I'm talking, of course, about the incredible transformation of raw crude oil. We are going to trace its path from deep beneath the Earth's surface through these massive industrial labyrinths right into your vehicle's fuel tank. It's a remarkably complex process of chemistry and engineering, and I cannot wait to unpack the whole shebang for you. Okay, let's take a quick look at our syllabus for today. First, we'll uncover the origins of fossil fuels. Then, we'll walk through the four main refining stages, starting with fractional distillation, moving into the cracking process, and hitting treatment and blending. After that, we'll compare the crucial byproducts derived from this whole process. And finally, wrap up with some highly unexpected everyday uses of petrol. So, Section 1, Origins of Fossil Fuels. You know, before we even touch modern refineries, it's actually super interesting that early civilizations, like the ancient Babylonians, discovered crude oil just naturally seeping up to the surface. They actually used it for waterproofing and construction. But where does this thick, black-yellow liquid come from in the first place? Well, when we pump crude oil out of the ground or from way beneath the ocean floor, we are literally tapping into ancient history. We're talking millions of years ago. Ancient marine organisms and vegetation died, sank, and settled at the bottom of the oceans. Over countless millennia, all that organic matter got buried under incredibly thick layers of mud and sand. And then, the Earth's immense geological heat and just crushing pressure slowly cooked and squeezed it, transforming it into the rich hydrocarbon mixture we know today as fossil fuel. Moving right along to Section 2, Stage 1, Fractional Distillation. Now that we have our raw material, we've got to process it. Because, well, if you just poured raw crude straight out of the ground into your car, your engine would be completely ruined. Before we go deep into the mechanics, let's just lay out the blueprint. Inside an oil refinery, raw crude has to pass through four main stages to actually become usable. First up is separation, where we divide the oil into its core parts. Second is conversion, where we break down the really stubborn bits. Third is treatment, to purify it all. And fourth is blending, where we mix in specific performance chemicals. So let's zoom in on that very first stage, separation or fractional distillation. To kick this off, the crude oil is pumped into these giant industrial furnaces, and it has to get hot. I mean, incredibly hot. We're talking 400 degrees Celsius. At that staggering temperature, the thick crude sludge literally boils and vaporizes right into steam and gases. Now, the absolute genius of the fractional distillation column is how it uses temperature to sort everything out. That 400-degree vapor gets fed into the bottom of a massive, super tall tower. As the vapor rises up, the temperature gradually cools down. And because different hydrocarbons have different boiling points, they condense back into liquids at very distinct levels. It's kind of like a giant sorting machine. The lightest substances, like LPG gas and your high-quality petrol, travel all the way up to the cooler top before they condense. Meanwhile, the heavy, dense stuff like diesel and asphalt, they barely make it off the ground floor, condensing at the much hotter bottom of the tower. All right, Section 3, Stage 2, the cracking process. This brings us to a fascinating engineering problem. What on earth do we do with all those stubborn, heavy leftovers stuck at the bottom of the tower? I mean, the modern world runs on petrol. We need way more of that than we need heavy road asphalt. So, distillation leaves us with these large, heavy hydrocarbon molecules that honestly aren't very useful on their own. To fix this, refineries use a process called cracking, specifically thermal or catalytic cracking. By applying immense heat, pressure, and chemical catalysts, which are basically substances that speed up chemical reactions without being consumed themselves, we literally shatter these large, clunky molecules apart. Through this sheer chemical brute force, we successfully convert that heavy, low-value oil right into high-quality petrol. It's pretty amazing. Next up, Section 4, Treatment and Blending Additives. Okay, so we've separated the oil and we've cracked the heavy molecules. But hold on, we still aren't quite ready to hit the gas station. Stages 3 and 4 are all about purifying our product and boosting its ultimate performance. Here's the thing. Raw petrol, right out of the tower, is just full of impurities. The absolute worst offender? Sulfur. If we leave sulfur in the fuel, it wreaks total havoc on a vehicle's engine, literally corroding the internal parts. And even worse, when it gets released into the atmosphere, it creates dangerous pollution and acid rain. So the treatment stage, where we chemically extract the sulfur and other harmful toxins, is absolutely non-negotiable for cleaner vehicle emissions and long-term engine health. Once that petrol is beautifully clean, we hit the fourth and final refining stage, blending. Refineries mix in highly specialized chemical additives here. You can think of these additives like a customized supervitamin for your car. They increase the fuel's octane rating, which stops engine knocking, and they also act as a lubricant to reduce engine friction. That directly improves your vehicle's overall mileage and efficiency. Only after this highly calibrated blending process is the petrol finally fully complete. Moving into Section 5, comparing crucial oil byproducts. It is so easy to fixate just on petrol, but crude oil is literally a master of multitasking. Let's look at the incredible variety of materials we extract during this whole distillation journey. To put this all into perspective, let's just look at one standard barrel of crude oil. That comes out to exactly 159 liters of thick, unrefined sludge. Honestly, it is mind-blowing how much diverse utility we managed to squeeze out of those 159 liters. When you compare petrol to its sibling products, it's pretty wild. Right at the top, the lightest fractions give us LPG for our kitchen stoves, plus petrol and naphtha, which, by the way, is the actual chemical foundation for making plastics. Moving to the middle, we get kerosene and aviation turbine fuel. That's the liquid keeping commercial jets in the sky. Drop down a little further, and we find dense diesel for heavy trucks and buses. Finally, sinking to the absolute bottom, we extract lubricating oils, Vaseline, and bitumen, which is that heavy, sticky asphalt we use to pave our roads. Every single drop has a purpose. And finally, Section 6, Unexpected Uses of Petrol. This is our last lesson for today's explainer. We all know petrol rules the highways, but its specific chemical properties make it incredibly versatile in ways that might completely surprise you. So, way beyond just transportation, petrol is a highly effective industrial solvent. It's routinely used to dissolve and manufacture paints, polishes, and even rubber. And here's one that usually shocks people. Certain specialized types of petrol are actually used in the dry cleaning process. Yeah, it is brilliant at breaking down and removing really stubborn oil and grease stains from clothing. Plus, it's an absolute lifeline for off-grid power, running everything from small portable generators during a blackout to heavy-duty water pumps on remote agricultural farms. It's truly staggering when you step back and realize just how deeply embedded this ancient, refined liquid is in our modern existence. I mean, from the roads we drive on to the plastics in our homes, right down to the dry-cleaned clothes we wear, crude oil is everywhere. Which leaves us with a massive, provocative question. With so many daily products and critical machines relying completely on fossil fuels, how will we manage to adapt to the future of energy? It's definitely something to ponder long after we finish up today. Thank you all so much for joining me in this explainer. Keep learning, keep questioning, and I will see you next time.